Okay, so in this video I'm going to consider exercise 71, which is to be found on page 22. Let's read the exercise. Okay, so we consider a polynomial with equation y equals 1/5 bracket x to the power of 4 minus 2 times x squared plus 25. Here you see a picture of the graph of that polynomial. Okay, so what do we want? Inscribe a rectangle into the finite area enclosed by the x-axis and the parabola. The rectangle should have the largest possible area and one side that lies on the x-axis. Work out the area of this rectangle. So we are dealing with an area of a rectangle, and that area should be maximal. Okay, so in a first step, let's try to visualize the situation. So here we have an area here enclosed by the x-axis and the parabola. So we are talking about the area, about this area here. So, and in this area we inscribe a rectangle. Okay, and moreover, one side of that rectangle should lie on the x-axis. So this rectangle will look somehow like that. So this is the thing we are considering. Okay, and now, because this parabola is symmetrical with respect to the y-axis, well, the y-axis is going to divide this rectangle into two equal parts. So this part here has precisely the same size as this part here. This will become important in a few minutes. Okay, so the area of the rectangle should be maximal, and this is my picture. Well, of course, we are going to need this point here and this point here. So I'm calling this point P and this point Q. Okay, so let's see. We say that P has coordinate x and y. Okay, then since this parabola is symmetrical with respect to the y-axis, Q will have coordinates minus x, y. Okay, so this here is x, and this here is minus x, and this side here is y. Okay, so what can we do with the area? The area of the rectangle, well, that's side times side. And now, if we consider this rectangle here, this side here, the total side here, has length 2 times x. So, and the other side here, of course, is y. So the rectangle has area 2 times x times y. And the good thing here, this is already my optimization equation. So the only thing left to find is we need, as usual, we need a relation between x and y. And here we are using the same idea as we've used so many times before. We are going to use the fact that point P lies on the parabola. So point P lies on the parabola. And from this it follows that the coordinates of P satisfy the function equation. I mean, this step here is so important. So it's important for you to understand that one. So this means that since the coordinates of P satisfy the function equation, we know that y, the y-coordinate of P, is in fact given by this. And this is already the second thing I need. So now I'm going to take this y here and I'm going to plug it into this equation, and then I will get an equation for the area containing just one single unknown. So the area of the rectangle is given by 2 times x times 1 over 5 bracket x to the power of 4 minus 10 times x squared plus 25. And this is everything we need. This is the function here whose maximum we are going to find. So what are we doing? Well, in the first step, it's a good idea to simplify this here a bit. So like this. And now, well, now I'm almost done, because now I'm going to take the derivative of that. This here is a constant factor, so it just remains as it stands. And then taking the derivative of what is inside the bracket is this. Now, taking this derivative and setting it as usual equal to 0 and solving for x. Well, if this product here is 0, then of course the second part here has to be 0. And now take your calculator and solve for x. X is going to be plus minus 2.24, or x is equal to plus minus 1. These are the solutions I have. So now here, of course, x is here, so x is positive. So this means I can ignore the negative solutions. Now let's quickly see whether both solutions work or just one of the two. So let's take f of 2.24. If you do that calculation here, then you will see that this is 0. Okay, so this of course doesn't work. So since, well, in fact, we want the area to be maximal and the area is surely not 0, so x has to be 1, and this leads to an area. Just plugging 1 into f and do the calculations leads to an area of 6.4. So what is important here, don't forget this one. It can be the case that you get here solutions that do not work, like this one here, okay? So sometimes if you get more than one solution, you need to check whether both solutions work or just one of them, okay? Thanks.